Yo, yo, yo! It's your boy, Mr. G here, coming at you live from DePaul. Hope everybody's doing okay today. So, this video is on scientific notation. So, what we're going to do is we're going to write, compare, and translate numbers in scientific notation and standard notation. Now, some of you might be saying, hey, Mr. G, I don't know what scientific notation is. And what it is it is a way to write a really, really, really big number. So we'll do something, I'm going to make a really, really big number here. It is a way to write a really, really, really large number in a way that is a lot easier to write down. So mathematicians are lazy. We do not like to write these gigantic numbers. To be honest with you guys, I don't even know what this number is, okay? And that's okay. It's a big number. So what we're going to do is we're going to rewrite this in a different way. So we don't have so many zeros, so it's easier to tell what the number is, and then so it's also easier to do mathematical problems with. Okay, so this is a really large number. We're going to change it to where it looks something like this. And then, I don't know, this is on, let's go. So, and then we're going to have to the power, to an exponent, okay? So this number is going to be translated into this number, or back and forth. This is what scientific notation looks like, okay? So what I want you guys to get down is in your foldables, if we have them. Whoa, this did not line up well. Hold on, let's see. It's okay. We'll make it work. Whoops. We have a large number in standard form to scientific notation form. Okay, all I gotta do is just move this over. Boom. Now we're on screen for the most part. So what we're going to have is we're going to have large numbers like this, and we're going to change them to scientific notation. We also might have really, really, really small numbers. It might even be smaller than this that we don't want to write so many zeros after a decimal. And we're going to also translate those into scientific notation. Now, what I want you to write down in your notes, and somewhere you can write this down anywhere, is scientific notation is always going to be one number, and then it could have a decimal, and then either one or two or multiple numbers after the decimal, times 10 to some power. This is what it's going to look like every single time. Okay? We're always going to have a single number before the decimal. It doesn't matter how many numbers we have after the decimal. It really doesn't. We could have 1, we could have 2, we could have 3, 4, 5. But what matters is that there's only one number after the decimal. This number before the decimal has to be between, we could write this down, between 1 and 9. Has to be between 1 and 9. Any numbers after the decimal, depending on how many it takes, and I'll show you what I mean by that in a little bit, and then we're always going to multiply that by 10 to some power. Okay, so that's just a blank where we're going to have an exponent. Okay, so this could be a 12, or it could be a 10, or an 8, or a 7, just depending on how large or how small the number is. Okay, so scientific notation will always look like this. Standard form, the standard form here, that's just what we know numbers as now. Okay, so I have this number, 350,600,000. That is just a number, and we call that standard form. That's not in scientific notation. That's just what the number looks like. Okay, now what we're going to learn today is how to convert this into scientific notation. So check this out. And this is what all of this is written down behind your foldables. But all this is already in there. And if you don't have it, please write this down. This tells you exactly what we need to do. So first it says move the decimal to the left, so I put that in a box there, until there's only one number in front of the decimal. So there is no decimal here, but we always know it could be on the end. This is like 0.0, right? So I'm going to move the decimal to the left until there's only one number in front of the decimal. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this one would have been 3 point. And then let's see what we got here. I got to rewrite this. Sorry, guys. I'm a little cluttered right here. I'm going to change this. Hopefully we got this down. And I missed my mark on my eraser. So we moved it 8 times. Okay. So now what we're going to have is I'm going to rewrite, drop any zeros at the end. So this is at the end, 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 this is at the end. I'm dropping all those zeros at the end. That's what it says right here. That means I have 3.4 506. It said to drop all these zeros at the end. I don't need to write those. That's the point of scientific notation. This is a shortcut to write this big number. I don't want to write all these zeros on the end. So I move my decimal until I have one number between 1 and 9. So I stopped it here right after the 3. 3.506. And then that's going to be times 10. And the number of places I moved my decimal is the positive exponent. So that's going to be times 10 to the power of 8 because I moved it 1, 2, 3, 4, 5, 6, 7, 8 times. I'm done. There's nothing else that I need to do. This is a number written in scientific notation. Okay? Questions so far? I guess I can't ask you guys that because you can't ask me any questions. Ha! All right. So now we also use scientific notations to express really small numbers. It is going to be the same process. Okay, so now I have a really small number. This is a lot of zeros after my decimal. Sometimes we'll have a lot bigger, smaller numbers than this. But it's the same exact process. So now I'm going to move my decimal to the right instead of to the left. So I have my decimal. I got to move it to the right until there's only one number on the left side of the decimal. I moved it over 1, 2, 3, 4. So I'm going to write what I have here. I have 5.0068. Okay. I need to drop any zeros before my number. So I can drop this 0, this 0, this 0, this 0. We don't need to write the zeros in front of here. And then that's going to be times 10 to the negative exponent of how many I moved. I moved 4. So that's 10 to the negative 4. So really when we're moving numbers from standard notation to scientific notation, it's mostly just counting. We got to move our decimal over, count how many times we move it over, write it down. And then we just got to make sure if it's a really small number, it's a negative exponent. And if it's a really large number, it's a positive exponent. Okay? I want you guys to try some on your own here, just to see how we do. I don't know why I did this, guys. I'm really sorry here. Let's move it over. Boom. Okay. So, I want you guys to change all of these numbers into scientific notation. That's all we're doing. Okay, so go ahead and pause the video, give it a shot, and then come back and check to see how you did. All right. So, I know right away my decimal has to go here because it's got to be between. This number right here has to be between 1 and 9. I got a 1 there. I moved it over 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 10 to the 9th because it's a really large number, which means I'm going to have a positive exponent. This one right here, I got to move it to the right. I'm going to move it 1, 2, 3 times. So that's 4.569 times 10 to the negative third. Times 10 to the negative third. Okay. Now, and it's a negative exponent because it's a really small number, and we had to move our decimal to the right. Here, I got to move it over 1, 2, 3, 4, 5, 6 times to the right. So I got 3.69 times 10 to the negative 6. It's negative because, again, we have a really small number. And then finally, my last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So it's 1.005948 times 10 to the 11th power. And we're done. Now, we're also going to have to go backwards. So you're going to have to change numbers that are in scientific notation. You're going to have to move them into standard form. So here are your rules here. So now if I have a number here in scientific notation, like 6.0849 times 10 to the 9th, if I have a number here written in scientific notation, I'm going to go backwards. So because this is 10 to the 9th power, the cool thing is because it's a positive exponent, I'm going to go to the right. And it's just telling me how many times I got to move my decimal to the right. So because it's to the 9th power, whoops, got a little freeze there. Because it's to the 9th power, and I want to change this into standard form from scientific notation, I'm going to move it over 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means I have to add my zeros. So here's my number in standard form. And you can add your commas in there to make it look nice and pretty. 6,084,900,000. And that's what this number really represents in standard form. Same thing with the negative exponent. but that negative exponent means we move to the left. So make sure we have these rules down. So because it's to the negative 4, I'm going to go to the left. 1, 2, 3, 4. Add my zeros, and there's my decimal. So I have 0.000500. Oh, we got to move these ones over again. Sorry, guys. I want you guys to give these ones a shot. We're just counting and moving them over. Okay. All right. Hopefully you paused it. If you haven't paused it yet, pause it now because I'm going to go over the answers. But it's going to be 1, 2, 3. And the cool part is, here's my little trick. I have to move it over once, twice to the right because it's a positive exponent. So I'm moving it to the right. It means I'm making a large number. So I moved it over 1, 2. And I know I have 10 spaces left. So that just means I have 10 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I like to add the commas in there because it just helps me check my answer to see that I have the right spot. There's the bell. Uh-oh. All right. 10 to the negative 6. Move it over to the left 6. That's 1. And then I have 5 zeros. 3, 0, 4, 5. Negative exponent, move it to the left. Move it over 1. And then I have another 6 zeros because I have 6 remaining to move. So I'm moving it over 7 times all the way to the left. 2, 3, 4, 5, 6. 1, 6, 0, 2. And you just add on whatever you have to the left. 1, 2, 3, 4, 5. We'd add more. 1 more 0. 6, 5, 0, 9, 8, 0. All right, cool, guys. And the last thing, just to kind of look at it, we're not going to really need to, I don't want to spend too much time on this video because I don't want you to have to watch any more of a video. But you will have to compare numbers that are in standard form and in scientific notation, so you guys can try this on your own. But really, if I have a number in standard form and I have a number in scientific notation, and I want to see which one's bigger, is this number bigger or is this way bigger? So I want to know which is the larger number. So what I would need to do is either convert this to scientific notation or convert this to standard form. I like to convert to standard form because then it's really, really easy to tell. So if I moved it over 3 times to the left because it's a small number, 0.0036 is definitely larger than 0.00067 because of that 3. So then I know once they're in the same format that I can just do my little alligator mouth going towards that guy. Oh, I forgot my joke. Okay, joke of the day. What keeps a square root in one place? Oh, I gave away the punchline. What keeps a square in one place? Square roots. Man, rough first video after a while. All right, guys. Hey, good stuff today. And hopefully this made sense. Do your best. If you have any questions, let me know. G out.